Good afternoon. Good afternoon. My name is Uma Maheshwari. I am here to tell about the sequential circuit in Unit 3 and in the topic of latches. Sequential circuit, that is the combination circuit and a memory element in a form of combination is called as a sequential circuit. What it will do means, like the input we are just giving it as an external inputs, and we will be getting a external outputs over here, and by using that one, from that output, the output it is being given to the next state of the input. So that internal input is called as a memory element. From that memory element we will be getting one output that will be just gone to the current state of the circuit. So this is called as a sequential circuit one. Here the sequential circuit contains a set of inputs and an output. The output of the sequential circuits depends not only on the combination of present inputs but also on the previous outputs. The previous output is nothing but the present state. Therefore, the sequential circuits contain combination circuit along with memory storage elements. Some sequential circuits may not contain the combinational circuits, but only the memory elements contains the combination circuit. Here the latch building block of a sequential circuit is capable of storing 1 bit information. It has two output states, Q and C complement, but it is a built from logic gates. Here the latches does not have clock signals. Instead it can have an enable line. The output changes only when enables the input signal is applied, and the latch is a level triggered one. Triggering means what? A state of a latch or a flip-flop is switched by the change of a control input. Here the level triggers is nothing but the latches, and the edge triggers is nothing but the flip-flops. This is the A, B and C. It tells the response of the positive level and the positive edge response, and this one is the negative edge response. Here the rising edge and the falling edge. The rising edge is nothing but when a bit combination of it is from 0 to 1 means that is called as a rising edge. The count it has been occurred from the arrow mark shows here, and it will be in a stable state when it is, if it is in the rising edge high position, and when it comes from high to low, then that is called as a falling edge, that is called as edge triggering. Here we will be seeing the difference of level triggering and edge triggering. Here it is of two types, that is the level triggering of two types. The edge triggering is also two types, but the level triggering gives the high level triggering and low level triggering. Here the edge triggering gives the positive edge triggering and negative edge triggering. The level triggering is the latch or flip-flop circuits which change their outputs only corresponding to the active high or low levels, are also called as level triggered latches or inputs. Here this is two types of are there in case of edge triggering: positive edge triggering and then negative edge triggering, whose flip-flops which change their outputs only corresponding to the positive or negative edge of the clock input are also called as a edge triggered flip-flops. The types of latches are SR latches, and then S is for the abbreviation of this SR is set and then reset latches. The next one is the D latch. D means delay latch, and next one is T latch. The T means toggling. Toggling means whether we are just giving a bit as 0, then the output will be 1. Whether that is an 1, the input is given as 1, then the output will be 0. This is called as toggling one. And the JK flip-flop, JK latch. These are all the types of latches. Here the latch is a SR latch with enable input using the NAND gate. NAND gate means AND with an inverter is called as a NAND gate. Here the logic symbol is also shown here. The truth table for SR latch which enable input are, the enabling means we will be giving the signal as enable from throughout the for all the combination of the input, that is SR and then Qn plus 1. The state is no change, reset, set, intermediate and then no change. Here the combination of the input is SR Qn, so 0 0 1 0 0 0 0 0 0 0 1 and 0 1 0 0 1 1 and so on till 1 1 1, that is from 0 to 7. So totally we will be having 8 combinations of input. Here in the case of SR latches, the characteristics equation is it is being applying in the K Karnoff's map. So this will be Qn plus 1 is equal to S plus R dash Q1. And then the excitation table is Qn plus 1 S and R, and the D latches we are just giving the enable as an input for both D delay loop, and the truth table for this logical symbol is shown here, and the characteristics equation and then excitation table is also shown here. For this D flip-flop, Qn plus 1 is equal to D. The advantages of latches are the designing of the latches is very flexible when we compared with the flip-flops. The latches utilizes less power. The performance of latches in the design of the high-speed circuit is quick because these are asynchronous within the delay design and there is no need of clock signal. The shape of the latch is very small and occupies less area. If the operation of latch-based circuit is not finished in the set time, they borrow the necessary time from other to complete the operation. Latches gives the aggressive clocking when contrast with the flip-flop circuits. The application of latches includes the latches are single bit storage elements, and latches are used in circuits like power gating and clock as a storage device. The D latches are applicable for asynchronous system like input and output ports. The assessment questions are: what is latch, and list the types of latches and the difference between level triggering and edge triggering. We'll see in the next video. That is the next topic we'll see in the next video. Thank you.